So a little bit more about the bell-shaped curve of the normal distribution. I apologize for the drawing, it's not entirely exact here, but this is a typically bell-shaped curve that you would find in a normal distribution. And we'll notice some features here. We said that the bell-shaped curve is symmetrically distributed around the mean. So the mean, it runs down the middle here. Let's just use a different color. Let's try green. So this is the mean value. And what you have in a normal distribution is that, well, okay, we model this as x is normally distributed, and we have the parameters which are the mean, and we have the variance. So if you have the variance, you also have the standard deviation. So standard deviation, that would be the square root of the variance. And for any normal distribution, generally we can say that 68% of the area under the curve lies between -1 and +1 standard deviation from the mean. So a distance of 1 standard deviation from the mean makes up 68% of the total area under the curve. So this is 68% more or less. Okay, let's try blue. So if I say, oh, it's almost invisible, isn't it? If I write two standard deviations, away from the mean. So now we're including the bit in the middle, and that should make up 95% of the entire data set. And 3 standard deviations from the mean make up 99% of the data set, like this. So what is this good for? Well, say you have a problem like this. Okay, you have the height of males, which is normally distributed in a population. Let's say that the mean is 178 centimeters and the variance is 16, or 4 to the power of 2. So that means the standard deviation is 4. So if you get the question, how many percent are 182 centimeters or shorter? And the way we can figure that out is, okay, well, we have the mean here, that's 178, and plus the standard deviation. Well, we could write that as S, right? That's 178 plus 4, so that's 182. So we're asked how many percent are 1 standard deviation more than the mean or less. So we're really talking about this area here. How many percent is that? Now, the mean makes up 50% of the data set. So that's half from the mean and down, that's 50%. So the mean splits the data set in half, right? So 50% is right here. And we want to add this bit here. We know that one standard deviation away from the mean makes up 68% of all the data. And if we take 50% and add this side of the 68, we should have 50% plus 68% divided by 2. So we want half of the 68%. And that's going to be 50 plus 34 equals 84%. So what I've done here is, okay, we've taken these 50%. Yeah, so this is 50%. 50% are 178 centimeters or shorter. And we've added one standard deviation to that, which is this area here. And we know that this area must be half of 68%. So we're just adding 34% to the 50. So that tells us, and we could also write the value up here, that here, the height here is 182 centimeters. So this is where, this is the border for 182 centimeters, so everything to the left of this is shorter than 182. Everything to the right is taller than 182. If you're asked about other percentages or other questions that don't involve 1 or 2 or 3 standard deviations, you will have to use a calculator to find the answer, and it's very similar to how we find the binomial probability distribution, but you just choose normal distribution instead of binomial.